Good afternoon, everybody. I am Suraj Bhan, Assistant Professor in Mechanical Engineering Department of IIMT College, Greater Noida. And today I am going to give lectures on impact of metal in nanoparticles as a food additive on engine performance and emission characteristics. And this is the introduction part of this topic. Actually, there are general concerns over increasing oil prices, rapidly depletion of the fossil fuel, national security of the supply, and the impact of greenhouse gases emissions of global climate change. Actually, everybody is concerned from these things that the petroleum-based oil is depleted rapidly due to increased demand of increasing populations, and so that their prices is on the high. This increased price of the petroleum-based oils directly impact the uh, national economy stability of the nation. And apart from that, when these petroleum-based oils burn into the transportation vehicle, it emits very harmful emissions like as the CO, CO2, and the NOx. Actually, these harmful emissions spreaded the air pollution, which is very dangerous for the human kind of the society. Actually, so that the potential, so that the research are looking towards the renewable source of the energy which can substitute this petrol based of the oil. Uh, so that the biofuel has been emerging as a potential biofuel which can substitute this petrol based of the oils. The potential of the biofuels appear to be enormous from an economical, political, and environmental perspectives. And speaking in terms of the advantages, much here is that they as an alternative could solve several issues amongst others. First, the increasing energy prices worldwide. Second, the increasing need of the energy imports. Third is negative environmental consequences of the fossil fuels. And fourth is security of the national energy supply for the many countries. Actually, this is the petrol-based energy consumption data. Energy consumption of the India by third of the rest of the world average energy consumption. Mostly energy consumption is taking place in, in our country, and the 34% of the energy requirement is fulfilled by the crude oil, of which 83% is the imported. So this imported oil very influences our nation economy. So we should have to be dependent on our itself energy resources. So we should have to make our energy resources. And the world transport heavily depend on the petroleum based oil. Everybody know and everybody concerned from this things that the transport vehicles play very vital role to consume the petroleum based oils. And apart from that, they emit very harmful emissions like the CO2 and the NOx and the particulate matters etc. And it is a data that the rise of the 22.48 percent in the car production as well as 9.16% in the truck production was recorded in from 2010-11 to 2020-21 in India. So this is the overview of the energy consumption data. And as we have discussed that the compression ignition engines like the diesel engines play very vital role in transportation, agriculture, and the civil construction and the power. And these engines are very reasonable, responsible for the emissions and for the harmful emissions and the consumption of the fuel. Uh, this is the limitations as we have discussed as smoke particulate, it emits the smoke particulate matters and the NOx emissions. So to keeping these factors like as the biofuel, and biofuel can be obtained easily from the waste cooking oils. Actually, waste cooking oil is a used cooking oil which can be discarded after using one and the two times into the sewages, and due to which the water pollution will be occurred. Uh, in the occurred and the water pollution is very harmful for the human beings. So it is very good and very good things to use the wastage like as the waste cooking oil as a biofuels by which the two target can be fulfilled. First one is that it can substitute the petrol based oil, Second, that the water pollution can be avoided by using this waste cooking oils. But it was seen that by the many researchers and from the literature review that when the biofuel is used with the diesel engines, the performance of the diesel engine decreased slightly, but there is a uh, slight, but there is a reduction and the improvement into their emissions, like as the CO2 and the NOx etc. So to enhance or to boost the engine performance, the nanoparticles, metal nanoparticles may be used as a fuel additives with the biofuel to improve the to enhance the engine performance and to reduce the emissions like the CO2 and the NOx. Actually, not even now only to increase the engine performance, but also nanoparticle enhance the physiochemical properties which are directly correlated to the engine performance and the emissions. So, nanoparticle enhance the physical property of the biofuels. After that, the later technology, like as the optimization technology, is usually used by the researchers and the scientists that they can optimization, they can optimize any system or the engine uh, through the various technology. Like as the response survey methodology is a very good technique uh, which can optimizes the engine responses at the appropriate input parameters. And about the about the biofuel molecular structure, it is very important to know about it because of the it was seen by the researcher that the biofuel molecular structure is similar to the diesel engine. The first thing is that because so that it can be easily used with the diesel engine without any modification without any modification into design of the engine. So this is the molecular this is the fatty acid composition of the various types of the biofuels. Biofuel contains the various types of the fatty acids like as the lauric, mystic, palmitic, stericolic, etc. And these are the fatty acids composition of the various types of the biofuels like as the sunflower, rapeseed, soybean, peanuts, olive, etc. So there is a very slightly change in their fatty acid composition due to which there is a slight change in the physical properties of the biofuel. So various type of the biofuel feedstocks has their slight change in their physical property like the viscosity, calorific value, density, iodine value, and etc. Density etc. So now, what is the effect of the biofuel compositions on the properties, emission, and the combustion characteristics of the CI engines? Actually, the composition of biofuel consists mainly the two types of the acids. One is the unsaturated free fatty acids, and second is the saturated free fatty acids. Unsaturated free fatty acids are those which consist the double bonds, and the saturated fatty acids which consist the single bond in the molecular structure of the biofuel. And the unsaturated carbons are free fatty acids like as the oleic acids, leonic acid, and linolenic acids, and the saturated fatty acid is the palmitic acid, acids, etc. Actually, the unsaturated acid consists the double bond and means that which contain the oxygen molecule, more oxygen molecule in compared to the other fatty acids, due to which the combustion uh, due to which the combustion of the biofuel take place at the higher temperature. Those biofuel which has the more unsaturated fatty acid, if this biofuel is injected into the diesel engines, the combustion will be take place at the higher temperature because the more oxygen molecule will be participated to the combustion. Not even only the combustion take place at the higher temperature, but the proper combustion will be take place due to which there is a decrement into the carbon monoxides, carbon dioxides, hydrocarbons, uh, smokes, but the NOx emission increase because at the higher temperature, more oxides of the nitrogen uh, generate. And and apart from that, the more unsaturated uh, more unsaturated fatty acids biofuel molecular structure has the lower density, lower oxidation stability, higher adiabatic flame temperature, better cold properties, higher iodine value, higher molecular etc. And the presence of saturated free fatty acids contain presence of saturated free fatty acids inside the molecular biofuel molecular structures has the higher are responsible for the higher viscosity, higher density, better oxidation stability, poor properties, less NOx, and has the more C10 numbers and the less ignition delay. But it was seen that the biofuel the biofuel which contains the more saturated fatty acids uh, gives the more BT maximal efficiency of the engines and reduce the brake specific fuel consumption. So these flow properties are good in the one things, but they are bad in the other things. Similar is for the unsaturated fatty acid. So research are looking towards to optimize these saturated and the unsaturated fatty acid at which the biofuel give the more engine performance and reduce the brake specific fuel consumptions and reduce the emissions. So research are looking towards it, and many research are looking towards it. And this is the comparison of the physicochemical properties of the different types of the biodiesels. Actually, due to their slight change in their fatty acid composition, the different types of the biofuel has the different physicochemical properties like at the flash point in time into viscosity, density, calorific value, and the CTAN value. But there is a very slight variation in their physicochemical properties because of there is a slight variation in their free fatty acid composition. Actually, free fatty composition are directly correlated to the physicochemical property of the biodiesel. So, different types of the feed stocks has a different types of the uh, viscosity, and there is a very slight change like the sunflower, rapeseed, soybean, peanuts, palm oil, etc. Now, it was seen that when the biodiesel is used uh, with the uh, diesel engine, so it was seen that by the researcher, its thermal efficiency decrease in compared to the diesel engine, in compared to the diesel oils, and the brake specific fuel consumption increase in compared to the diesels and the petroleum based oils and the CO2 and the unburned hydrocarbon emission decreases, but the NOx emissions increases. So to improve the engine performance and to decrease the NOx emissions, the nanoparticles are added with the biodiesel to boost the engine performance and to reduce the emissions. Actually, what is the reason behind that? Why the nanoparticles, why the nanoparticles addition reduces the emissions and increase the engine performance? Actually, nanoparticle has the highest surface to volume ratio due highest surface to volume ratio. When the nanoparticles is blended uh, with the diesel, and with the diesel, so diesel exposes the more surface to the air, uh, due to which it accelerates the evaporation process and the heat transfer rate will be increases and the ignition more ignition delay will be reduced and the engine performance will be increased. So addition of the nanoparticle, apart from that, the addition of the nanoparticle improves the physicochemical property of the biofuel. It increases the calorific value of the fuel. The increased calorific value of the fuel gives them more engine performance. And apart from that, it improves the combustion characteristics as we have discussed that when the biofuel is blended with the diesel, the proper atomization of the fuel take place inside the engine, and uh, the nanoparticle has the high surface to volume ratio. It exposes the more surface to the air, due to which it accelerates the evaporation process and the ignition more early ignition will take place and the ignition delivery will be reduced and the engine performance will be increases. And Apart from that, it is the fuel droplet propagation, injected fuel dispersion, and the better air fuel mixing, and reduce cylinder pressure, reduce increase the heat release rate. And the metallic nanoparticle like as aluminum oxide, copper oxides, etc., which contains the oxygen molecule due to which it supports the combustion process and reduces the CO and the other hydrocarbons. So the addition of the nanoparticle increases the more oxygen molecule into the combustion. So the combustion characteristics will be improved. So nanoparticles additives may be proved as a very good fuel additives to enhance the engine performance and reduce the emissions. Actually, these are uh, this is the impact of the nanoparticles as fuel additives on the fuel on the biofuels physicochemical properties. So here is some data, and the biofuel and the nanoparticle addition increases the calorific value of the biofuel as seen on the slides. And the jet surface bio when the aluminum nanoparticles 30 ppm mixed with the jet surface biodiesels, it improves the calorific value of the biofuel, and its calorific value is 40.90. Without addition of the aluminum oxide nanoparticles, their calorific value is less compared to that. And when the nanoparticle is added with the diesel engine, is increase also the calorific value of the diesel engine. So not only the calorific value but also improve the other physicochemical property like the flash point and the kinetic viscosity, etc. So it is a very metal and particle made to as a good fuel additive. And this is also the data of nano biofuel blends. And how can we use the nanoparticle as a fuel additives? It is seen here. So the slides. First of all, we will select the biodiesel feedstocks, and after that, we will check their physicochemical properties. And if these are the physicochemical properties suitable, then we will go ahead, and after that, we will produce the biodiesel. And the biodiesel can be produced by the transesterification process. Actually, the transesterification is a very good worldwide accepted process, very cheap process, and good process through which we can prepare the biofuel. During this process, the biofuel is mixed with the alcohol with inappropriate molar ratio uh, with the catalyst. The catalyst may be the KOH, NOH, and the H2SO4. It is used according to the suitable biofuel feedstocks. And after mixing the catalyst and the alcohol with the biofuel, it is heated into the range of 70 degrees Celsius, and a good suitable RPM is provided to a whole whole feedstocks. So it was to a whole system, to a whole system. So after the two and the 3 hours, it was seen that the two layers are formed, and one layer is of the pure biofuel, and the second layer is the glycine layer. This glycine layer has the higher density. It is a very heavy layer. So due to the sedimentation process, it is separated out from the biofuel. After that, we will obtain the pure biofuel. But after that, we will follow the water washing process. During the water washing process, the heated water is poured into the biofuel. Because of heated water has a higher density compared to the oil, so it carries the remaining residuals with it carry the remaining residuals, and the pure biofuels layers is obtained above the heated water, and we obtain the pure biofuels. After that, we will follow the drying process. Actually, during the drying process, the biofuel is heated above the 100 degrees Celsius because of when the water during the water washing process, when the water is blended, the heated water is blended with the biofuel. The biofuels contain the some moisture molecules. So to remove the moisture molecules, we follow the drying process, and in the drying process, this uh, water moisture molecule will be vaporized, and we obtain the good biofuels. So during the transition during the esterification process, we obtain the pure biofuels, and after that we check again the physicochemical properties. So we find that the biofuel has the biofuel has the 1 by 10 times of the viscosity of the initial crude biofuel. So transesterification is a very effective process to reduce the viscosity of the biofuels. After that, we will analyze the inner performance of the emission for the biodiesel. It was find out that researchers that for example, efficiency is slightly decreasing compared to the diesels, and where gas fuel consumption increase is slightly compared to the diesel. So to improve the engine performance, we selected the suitable type of the nanoparticles, uh, like as aluminum oxide, copper oxides, etc. And after that, we will check the physical properties of the nanoparticles, and to check this. To check the physical properties, uh, and we also go on the analysis of the XRD and the SEM. XRD and the SEM is a technology which check the morphology of the nanoparticles. And after checking the XRD and the SEM, we prepare the biofuel. Uh, After checking the XRD and the SEM, if you find that this is a suitable or this is a good nanoparticle to use, then we use this nanoparticle with the biodiesels. And we take the different type, we added the uh, different contents. We may add the different contents of the nanoparticles into the biodiesel. After that, we again check the physicochemical properties of the nano biodiesels, and many researchers see that there is a changes into the physical property of the biofuel of the nano biodiesels, and after addition the nanoparticles, the calorific value increase. There is improvement in the viscosity, density, calorific value, and the iodine value, and the etc. Again, after checking the physical properties, we again check the we injected this nano biodiesels into the diesel engines and evaluate the engine performance and the emission for these types of the samples. And it was seen that by the researchers that there is a good improvement in the engine performance, and there is a good reduction in the emissions of the diesel engine. So these tests show that nano biodiesel may be proved as a substitute fuel for the petroleum based of the oils. So this is a overview of the analysis. This is the experimental setup, and this is the transesterification overview of the transesterification, and this is the physiochemical properties of the waste cooking oil, and this is the waste physical properties of before apply the transesterification and after apply the transesterification process, and this is the XRD and the SCM of the aluminum oxide nanoparticles, and this is the physicochemical property of the nano waste cooking blends. After addition of the uh, uh, this blend is showing that after addition the nanoparticle there is a improvement in the calorific value of the waste cooking oil. Next, these are the graph. This is the variation of the specific fuel consumption with the respect of the load. It was saying that addition of the nanoparticle show the reduction in the specific fuel consumption of the biodiesel compared to the other samples like the diesel, B20, and the other samples. And this is the variation of the breakdown efficiency with respect to the load. It was seen that the additional nanoparticle enhance the engine performance compared to the B20 and the diesel. And this is the CO emission with respect to the load, and it was seen that the addition of the nanoparticle reduce the CO emissions also in compared to the other samples. And similar phenomena is for the hydrocarbons. And when the nanoparticle is added with the biodiesels, the hydrocarbon will be level. And this is the NOx emission. There is a very slight change in the NOx emissions. So the consequently it was seen that the addition of the nanoparticles reduce the emissions and improve the engine performance. So it can be proved as a good substitute of the petrol-based oil.